In this video, we're going to solve horizontal projectile problems. So here's our first problem. We have a golfer practicing on a range with an elevated tee 4.9 meters above the fairway. And it's able to strike a ball so it leaves the club with a horizontal velocity of 20 meters per second. And then they have a little picture here of what happened. So our first question says, how long after the ball leaves the club will it land on the fairway? The first thing you always want to do is solve for time. Always. Okay, so we know we have a height of 4.9 meters and we have a Vx, or a horizontal velocity, of 20 meters per second. We also know that because the projectile was launched horizontally, or the golf ball, our initial y velocity is 0. And then we know g, which we've memorized and all that, and we all know it's 9.8 meters per second squared. Okay? Then we have a couple formulas that we can use. We have a couple formulas that we can use for these problems, and I'm going to write them over here just so we've got them where we can easily look at them. Now, the first thing I like to do for these problems, even before I solve for time, is I want to go ahead and draw a picture of kind of what's going on here. So we have this golf ball, it's launched from a cliff kind of like this. The motion's actually going like that, and we're going to draw a right triangle. Okay, and we know this. Our horizontal velocity is 20 meters per second. Okay, so the first thing we want to do is go ahead. So if you look at the formulas, we don't know a final y velocity yet, so we can't use that one to solve for time. And we don't know a horizontal distance, so we can't use that one to solve for time. So we have to use this one. We'll never have to solve a quadratic. So if you get somewhere and you get stuck and it looks like you're going to have to solve a quadratic, you probably made a mistake somewhere and you can go back and fix and see what you did. So this one looks like we'll probably have to solve a quadratic. So the best thing to do is plug in our numbers and see what we have. And that way usually something kind of falls off. So our initial y velocity is 0 meters per second. And so eventually we'll be able to go ahead and cross that out. So we can just get rid of that. And then we have a little simpler problem. So I'm going to have 4.9 meters equals, and then this right here, 1/2 times 9.8 is also 4.9. So then we're going to go ahead and we're going to divide both sides by 4.9 meters per second. And we're going to get 1 second equals t squared. So then we can square this. The square root of 1 is 1, and our time is 1 second. Okay, so we've solved part A. Okay, the next thing the question says is it wants to know what horizontal distance will the ball travel before striking the fairway. Okay, so we're going to want x. If you look at our formulas, this one is the only one that has a horizontal distance. And since we solve for time, we have that and we have our horizontal velocity because that stays the same all the time. So you'll want to find the horizontal distance. We have Vx equals x over t. We can put this in the triangle. We have Vx on the left, x over t, and then so our formula will be x equals Vx. We'll just plug in our numbers, 20 meters per second times 1, and we'll get 20 meters, which is our answer. Now, the next thing they ask us, if you can see this, is they want to know the acceleration of the ball 5 seconds after being hit. So we've got this golf ball, okay, and it's going at a constant 20 meters per second horizontally. So that means there's no horizontal acceleration. This ball that's starting with 0 velocity, y-axis, and then ends at some final velocity, and it accelerates downward at 9.8 meters per second squared, which is gravity. So our vertical is 9.8 meters per second squared down. Okay? Now, if you look up here, then we have, the next one says calculate the speed of the ball 0.8 seconds after it leaves the club. 0.8 seconds. Now this is shorter than our time up here, so that lets us know it's still going to be in the air, and we're just going to use this for our time. And we basically want our horizontal velocity and our final y velocity. And so our horizontal velocity stays the same. So it's still going to be 20 meters per second, which is really nice. We don't have to do any math there. And then we need to find our final velocity. So if you look at our formulas we have up here, we can actually use this one. So then we have the initial y velocity, gravity, and time. This one does not have a final velocity anywhere, and neither was this one. So we'll use this one. So we want our speed at 0.8 seconds. So we're going to do 0 meters per second, which is our initial y velocity, 9.8, which is our time, is our acceleration, and we're going to use this time right here. Okay, I'm going to multiply these two together. Okay, you can see in my calculator, I'm just multiplying 9.8 times 8, and I'm going to get 7.84. So that's my final y velocity, 0.8 seconds. Now, part E says, with what speed will the ball strike the ground? So this is an impact velocity. You can see I already kind of wrote it, erased it. We want our impact velocity. And we're going to use the same formula we used right here, except we're going to put 1 second in for our time instead of 0.8, because that was the time we found up here. So our initial y velocity is still 0, didn't change. Our acceleration is 9.8, and our time is 1. You put those two together, you get 9.8 meters per second as your final y velocity. So now that we have that, if you look back up here, here's our triangle. We have 9.8 here for this y part of the triangle, and now we can go ahead and we can solve for this hypotenuse, and we're going to have to use the Pythagorean theorem for that. So we have a squared plus b squared equals c squared. Okay, so we're going to take 20 meters per second squared and 9.8 meters per second squared equals c squared. Now, I know you guys use this in math a lot, so I'm going to go ahead and I'm going to just kind of put my numbers in. So I got 496.04 meters squared second squared, and then I'm going to square that, and we're going to get 22.27 meters per second. And that's our vector velocity. But we're still not done, because if you look here, we need to find this angle right here. So we're going to use the inverse tan formula from our last chapter. And so we're going to go tan -1, the y component of the triangle over the x component. Okay, so we have tan -1. Our y component is this 9.8, and our x component is that 20 velocity, that 20 meters per second velocity. So now we can put this in our calculator. 9.8 divided by 20, take the inverse tan of that, and you're going to get 26.0 degrees. And so now you're done, and we've solved an entire horizontal velocity problem. Remember, first thing you always want to do is solve for time. And then once you've done that, you've got a bunch of stuff to work with, and you can just kind of keep going and see what you need and just look at those formulas. And I like to have these formulas somewhere where I can always look at them, and that way I can see them all the time and I can refer back to them, and I know I can check which formula I need to use.